Hello everyone. On today's video we will be covering scientific notation. Okay, so a brief description as to what a scientific number written in scientific notation is. It's a positive number. Usually it's very large or a very small number. Okay, it's written as a scientific notation if it is written as a product of a number, and we'll call that number A, where A is between 1 and 10, or it can equal 1, it just can't equal 10, it has to be less than 10. So it's greater than or equal to 1 or less than 10, and an integer power of r of 10. Okay, so in other words, it's written as some number A times 10 to the power of the exponent r. Okay, so now we're going to look at the steps to convert a number to a scientific notation. Alright, so your first step is you're going to move your decimal point in the original number so that the new number has a value between 1 and 10. Remember, it can't equal 1, but it does have to be less than 10. Okay, so your second step is you want to count the number of decimal places the decimal point moved in step 1. Okay, so where they move to the right or to the left doesn't matter. You want to count the number of spaces. Okay, now you focus on the original number now, because if the original number is 10 or greater, then the count from here stays positive. But if the original number is less than 1, then the count becomes negative. So let's say if you move 6 decimal places, if your original number is 10 or bigger, then that would stay positive 6. But if your number is less than 1, then that's going to become a negative 6. Okay, now your third step is now you're basically going to combine steps 1 and 2. So you're going to multiply your new number in step 1 by 10 raised to the exponent equal to the count in step 2. Alright, so if you're still writing, feel free to continue writing. But we're going to go ahead and press pause and then continue writing. But we're going to go ahead to our first group of examples. Alright, so let's say, for example, we want to write as a scientific notation. Say for problem A, where if we have 367 million, and for problem B, we have 0.000003. Is 1, 2, 3, 4, 5, 0. Okay. Okay, so we're going to go through each step. Okay, so for problem A, if we have 367 million, remember when there's no decimal place, the decimal's all the way to the right. So what we do is we get it and we move it 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we move the decimal, moved 8 places, and our new number is 3.67 because the decimal moved right there. Okay, remember your first step is you want the number to be between 1 and 10. You want it greater than 1, greater than or equal to 1, but less than 10. And that's 3.67. Okay, so that's your first step. Okay. Now your second step is we know that this original number is greater than 10. So since the original number is greater than 10, the count of 8 decimal places moved stays positive. Okay, so that means that your count equals positive 8. Okay, so you have your new number and your count. Okay, now we go to our third step. Where we basically combine those two. So you multiply step 1 times 10 raised to the count value. Okay, so basically your scientific notation becomes 3.67 times 10 to the 8th power. Okay, so that is your scientific notation. Okay, so really all of this writing isn't really necessary. I'm just doing it for educational purposes. But you'd write your new number, your count, combine them. 3.67 times 10 to the 8th power. Okay, and this is your answer. Okay, so what about problem B? And you kind of separate that a little bit. So for problem B, we have 0.000003. Now we're going to move this decimal. Uh-oh. Sorry about that. Here we go. We're going to move this decimal 1, 2, 3, 4, 5, 6 places to where it's just 3 point or 3.0. Okay, so decimal moved 6 places. So your new number remember, when the decimal moved all the way to the right, the new number is just 3. Or some may like to use 3.0. Okay, so that's your new number. Okay, now we go to our second step. Remember, this is first step. Well, your first step is up here. Here we go. Now your second step is you know that since the original number is less than 1, the count of 6 decimal places becomes negative. Okay, so that means your count is equal to -6. Okay, now your third step is you have your new number. So you're going to multiply step 1 times 10 raised to the count value. Okay, so in other words, you have 3.0 or 3. If you want to use just 3, you'll be okay, or you should be, times 10 to the negative 6th power. And that is your scientific notation of 0.000003. Alright, so if you're still writing, feel free to press pause. We're going to go ahead and do a couple more examples. Okay, so let's say, for example, to write as a scientific notation. Okay, say for problem A, we have 20,520,000,000. Yep, that's a little too much space. Get those a little closer together. That looks, straighten that up so it's a little clearer. There we go. And let's say for problem B, you have 0.00085. Okay, now what I want you to do is I want you to go ahead and press pause and try to solve these on your own using the same steps from the previous two examples. Alright, so assuming you've already pressed pause and worked these out, we're going to go ahead and solve them. We'll start with problem A. So I'm not going to write down all of the extra stuff. I'm just going to go ahead and solve it. Okay, so your first step, so you have 20 billion, 520 million. Remember, when there's no decimal, it always starts at the far right. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you move 10 decimal places. Okay, so that means your new number is 2.052. Okay. Now your second step, your original number is greater than or equal to 1. Make greater than 10, so sorry about that. So the count stays positive. Okay, so I've kind of cut back on the writing on this one, so your count equals positive 10. Okay, now your third step is you just combine the two. So you have 2.052 times 10 to the 10th power. Okay, so that's your scientific notation. Alright, so we go to problem B. You have 0.00085. You have your decimal here, so we move it 1, 2, 3, 4 places. Move 4 decimal places. So your new number is 8.5. Okay, now a hint is you want to move your decimal till there's only one digit to the left of the decimal point. That's why up here we moved it all the way until we got to the 2, between the 2 and the 0 here. And here we moved it all the way till we got between the 8 and the 5. Okay, so you want only one decimal place to the left of your decimal point. That's why you move it. Okay, so hopefully that makes it a little easier to understand how many places you want to move the decimal. Okay, so your second step, your original number, this is actually less than 1. So count becomes negative. So that means your count, instead of 4, becomes negative 4. Then we go to your third step, where we just combine those two. So you have 8.5 times 10 to the negative 4th power. Oh, sorry about that. Looking at the paper instead of the screen. Okay, so that would be your scientific notation. Okay, so with a little bit of practice, actually you can become really quick at solving these. Because once you do them a few times, usually the steps just jump right out at you. The main thing is to remember where to move the count decimal points. If you want to move the decimal to the right or not right or left, if you want to move it positive or negative, you have to remember that the count has to be greater than 10 or less than 1. Okay, so that's to convert a number to scientific notation. What if we want to convert a scientific notation to a number? Okay, so we kind of switch it up a little bit. All right. So now we're converting a scientific notation to a number, or a whole number. Well, really a number. Okay, so your steps involved there. Your first step is if the exponent is positive, you want to move your decimal R number of places to the right. Okay, so remember this is in A times 10 to the power of R form. Okay, you want to convert that to a number. Okay, so we'll call that 1A. If the well, first you want to write down the decimal number A. Sorry, I'm forgetting a step here. So write down the decimal number A. Here we go. Step 2. We'll remove the decimal point. on step 1. Now we go if the exponent is positive. If the exponent is positive, move the decimal R places to the right. Now, if the exponent is negative, you move it R places to the left. If the exponent is negative, move the decimal R places to the left. Okay, so that would give you your scientific notation written as a regular ordinary number. All right, so let's say, for example, we wanted to convert 8.63 times 10 to the third power to standard form. Okay. Now, following the steps, we write down our decimal number, which is 8.63. Okay. Now, for your second step, you see here the exponent is positive. Move that up a little bit. Since the exponent is positive, sorry about that. Let me kind of straighten that out a little bit. Since the exponent is positive, move the decimal 3 places to the right. So I might as well just write the number 3 instead of the word. Okay, so 3 places to the right, so that means 8.63. We're going to move it 1, 2, 3. Okay, now you notice you only have 2 values to the right. So if you move it 3 spaces, you have an extra space. Any extra spaces you moved it, fill them with a 0. Okay, so that means if you write 8.63 times 10 to the third power in standard form, you get 8,630. Okay, so filling, actually I'll write that right under here. Fill any extra places with 0. Okay, so let's say we do another example. Move that over a little bit. Okay, so let's say, for example, we want to convert 7.29 times 10 to the power of negative 3 to standard form. All right. Again, our first step is we're going to write down our decimal number. So we have 7.29 7.29. And really, you can do steps 1, 2, and 3 1 and 2 all in one number. I'm just kind of breaking it down. So if you have 7.29 and that's negative, you just move it, but I'm going to go step by step. So your second step, since the exponent is negative, move the decimal 3 places to the left. Okay, so that means your 7.29, you're going to move that 1, 2, 3 places to the left. Okay, and remember, you fill in the extra spaces with 0, so we're going to fill those two up with 0. All right. So that means we're going to have a value of 0.00729 as our standard form. Or sometimes instead of 0.0, you may see 0.0, which is okay. As long as you have the decimal and 2 values to the right, 2 zeros to the right, and then the rest of the number, you're okay. Okay, so now we're going to do a couple more examples. Okay, so what if we want to clean that up a little bit, convert to standard form? Okay, so let's say for problem A, we have 1.02 times 10 to the 5th power. Let's say for problem B, we have 7.358 times 10 to the negative 3 power. Let's say for problem C, you have 8.4 times 10 to the 7th power. And let's say for problem D, we have 3.007 times 10 to the negative 5th power. Alright, so what I want you to do is press pause and solve these the same way that they were solved in the previous 2 examples. Alright, so assuming you have pressed pause and you are all done, to solve A, remember, first thing we do is you write down, and I'm not going to write down step 1, step 2, step 3, I'm just going to do it straight through so you can see just how quick it is once you get used to it. Write down your first value, 1.02. You see that exponent is positive, so we move it 1, 2, 3, 4, 5 spaces to the right. Fill those in with zeros, and that becomes 102,000. Okay. So again, once you get used to the steps and you get some practice in, it's really, really quick. Okay, so for problem B, you have 7.358. Oh, actually, I should move that over a little bit because that exponent's negative, so we're going to have to move the decimal to the left. So it's 7.358. So if we move it, the negative exponent 3 places to the left, 1, 2, 3, where we have our decimal point here, and we fill in any empty places with zeros. So we have 0.007358. Okay, remember that first zero on the left of the decimal, you don't need it, but sometimes handy to put it there. So if you just have 0.007358, that's correct also. You just put that zero in front because sometimes it will show up that way. Alright, so if we have problem C, we have 8.4 times 10 to the 7th. So we have 8.4. That 7 is positive, so we're going to move it 7 places to the right. 1, 2, 3, 4, 5, 6, 7. And fill the rest of those in with zeros. Okay, so we have 84 and 1, 2, 3, 4, 5, 6 zeros. So we have 84 million. And for problem D, we have 3.007 times 10 to the negative 5. So 3.007. That exponent is negative, so we move it 5 places to the left. 1, 2, 3, 4, 5. We have our decimal here. We fill all those with zeros. So we end up with 0.0000307. Okay, so again, once you get the steps down and you understand whether you have to move the exponent to the right or left, it's really not too bad. Alright, so what if we wanted to multiply or divide scientific notation? Okay, let's go ahead and do a couple of examples of that. Alright. Okay, what if we wanted to write each result in standard form? Okay, so let's say for problem A, we have 8 times 10 to the negative 6 power, and that times 7 times 10 to the third power. Okay, so let's say if we have for problem B, if we have 12 times 10 squared over 6 times 10 to the negative 8 power. Okay, so those are a little bit different than the previous examples. Okay, so for problem A, what we're going to do is we're going to kind of break that down a little bit. Okay, so if you have 8 times 10 to the negative 6 power times 7 times 10 to the third power, if you notice, this is just all multiplication. Okay, so you can't use the FOIL method because the FOIL method is something plus something and something plus or minus something and plus or minus something, but this is all multiplication. So what we're going to do is we're going to rewrite it as all multiplication. So really this is just 8 times 10 to the negative 6 power times 7 times 10 to the third power. So it's the exact same thing, just written in a more familiar way. Alright, so now if you remember, multiplication is commutative. We can move these around. So what we're going to do is we're going to go ahead and move those around a little bit. So we have 8 times 7 times 10 to the negative 6 times 10 to the third power. Okay, all we did was move them around. Okay, so we can combine those two. 8 times 7 is 56. Okay, so we have 56 times, if you remember, x to the m times x to the n equals x to the m plus n. So whenever we have the same base and we're multiplying two values with an exponent, we just add the exponents. So if we have 10 to the negative 6 times 10 to the third, that's just 10 to the negative 6 plus 3. We just add those exponents since they both have the same base. Okay, and that will give us 56 times 10 to the negative 3. Okay, now to write this in standard form, we would just move the decimal over, but I'm going to show you how to write this as a standard deviation. I mean, not standard, as a standard notation first, or scientific notation, because this is not the scientific notation form. Okay, so if we wanted to write that, I'll write them in both. So remember, this exponent is negative, so you have 56. And we move the exponent 3 places to the left. 1, 2, 3. Fill it in with a 0. And that's 0.056. That's actually your standard form. Okay. Now, if we wanted to write this, it may look like this is in scientific notation form, but it's actually not, because remember, this value A has to be greater than or equal to 1, but less than 10. 56 doesn't fall into that category. Okay. So what we do here is, I'm just going to move that down here. We have 56. We get 56 and move that to the left once, then that gives us 5.6 times 10 to the first power. Okay, so 56 is equal to 5.6 times 10 to the first power. Okay, so that means instead of 56 times 10 to the third power, so 56 times 10, let me kind of separate that, 10 to the negative third power, that becomes 5.6 times 10 to the first power, because we just replaced 56 with 5.6 times 10 to the first. And that's still times 10 to the negative 3 power. That's already here. Okay, so if we go ahead and add those two, we have 5.6 times 10 to the 1 plus negative 3. So that would be 10 to the negative 2 power. Okay, so all we did was what we did up here was once we have the same base, we just add the exponents. So since we have the same bases here, we add those exponents. Okay, so even though the answer just asks for standard form, I figured I'd show you this because sometimes they will want you multiplying this and ask for it in scientific notation. Okay, so this is how you would do that. So I wanted to make sure both bases were covered. Alright, so now let's go to problem B. And again, if you remember, this is just a regular, ordinary multiplication and division problem. So if you have 12 times 10 squared over 6 times 10 to the negative 8 power, you can separate those. Because you have 12 over 6 times 10 squared over 10 to the negative 8th power. Okay, so all we did was separate it. We still have 12 times 10 squared over 6 times 10 to the negative 8. If we wanted to write them as one quotient. Okay, so if you notice here, 12 divided by 6 is 2 times, and if you remember your rules for dividing exponents, you have x to the m over x to the n equals x to the m minus n. So you have 10 squared over 10 to the negative 8 will equal 10 to the 2 minus negative 8. Okay, so we will end up with 2 times 10 to the, I guess you could say, 10th power. Oh, there's a... Okay. Now this, or 2.0 if you wanted to, this is your scientific notation. Okay, now remember, since your exponent is positive, you want to write that in standard form. That's just 2. We're going to move our decimal to the right 10 places. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and fill those with zeros. Okay, so this would be our standard value. 20 trillion. All right, so hopefully that kind of clears it up a little bit on how you would handle these. But let's kind of mix it up a little bit more. Alright, so what if we wanted to write in standard form and scientific notation? I'll just put that in there. Say for problem A, we have 0.0037 times 0.000024. And let's say for problem B, we have 0.000125 divided by 5,000. Okay, so really all we have to do is we have to remember that these are just numbers multiplied. And for B, they're just numbers divided. Okay, so for problem A, if you have point, run out of pencil lead here. Here we go. You have 0.0037 times 0.00000024. Okay, now first thing we want to do is we want to convert that to scientific notation. Okay, so if we move the decimal place 1, 2, 3 places to the right, we have 3.7. Since we moved this, the original number is less than 1. The exponent's negative. Okay, and this one we move it 1, 2, 3, 4, 5, 6 places. So that's times 2.4 times 10th, and since the original number is less than 1, it's going to be a negative exponent. Okay, now if you remember on the previous example, this is all just multiplication. This is 3.7 times 10 to the negative third power times 2.4 times 10 to the negative sixth power. So we're just going to go ahead and move them around. So that gives us 3.7 times 2.4 times 10 to the negative 3 power times 10 to the negative 6 power. Okay, so 3.7 times 2.4, that gives you 8.88 times 10. Since we have the same base, we just add our exponents. So 10 to the negative 3 plus negative 6 is 10 to the negative 9. Okay, now every once in a while they may tell you to round it to the nearest tenth or something like that. So this would be your answer for your scientific notation. But if you want to write it in standard form, of course, you just get your, I'll have to give it some room here, 8.88, because we're going to move it 9 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we fill those in with zeros. So that gives us 0.0000000888 as our standard form. Okay, so now we do the exact same thing for B, but in this case it's just going to be division. Okay, so for problem B, we do that very same thing with 0.000125 divided by 5,000. Okay, so really we can just go ahead and rewrite that as 0.000125 divided by 5,000. Okay, now if we want to convert this to scientific notation, you can go ahead and do that. You're going to move this decimal 1, 2, 3, 4 places to the right. So you have 1.25 times, since the original number is less than 1, your exponent is going to be negative 4. Over 5,000, we're going to move that decimal 1, 2, 3 places to the left. So we have 5 or 5.0. Since the original number is bigger than 10, it's going to be 10 to the third power. Yep, straighten up the paper there. There we go. All right, now remember, just like before, this is just multiplication up here. This is just multiplication down here. So we can go ahead and separate those. We have 1.25 over 5, or 5.0, doesn't matter, times 10 to the negative 4th power over 10 to the 3rd power. Alright, so 1.25 divided by 5 is 0.25. So you have 0.25 times 10 to the negative 4 minus 10 to the 3rd power. Divided by 10 to the 3rd power is 10 to the negative 4 minus 3. So that gives you 10 to the negative 7. Because remember, x to the m over x to the n equals x to the m minus n. So that's negative 4 minus 3 is negative 7. Okay. Also remember, this is not in scientific notation form, because that value of a has to be between, well, greater than or equal to 1 and less than 10. So that means we're going to have to move that decimal over once. Okay, so moving that over here, 0.25, if we move that decimal to the right once, that's equal to 2.5 times 10 to the negative 1 power. Okay, so we're going to replace that 0.25, 2.5 times 10 to the negative 1 power, and that's times 10 to the negative 7 power. Okay, so once we combine those two, that's going to equal 2.5 times 10. So the bases are the same, so we just add the exponents. So that's 10 to the negative 1 plus, well, negative 1 plus negative 7, which is negative 8. Alright. So that gives us our scientific notation. Now for your standard form, we're just going to move that decimal to the left. So you have, give that a little more space since we're going to be moving it to the left. So we have 2.5, and we're going to move that decimal to the left. 1, 2, 3, 4, 5, 6, 7, 8 spaces. And fill those in with zeros. So that gives us 0.00000025 in standard form. Okay, so we have both our scientific notation and our standard form. All right. So, leave that up there. That is it for our scientific notations and converting them into standard form and scientific notation form. Hopefully this video made sense, and I will see you on the next video.